Let us have a brief look at how we can use this dada2 R package and a function from there to plot the quality profiles of our FASTQ files. So here I have made a small R script where I load the dada2 package. I also read in the sample table that we have, and let me just make sure we run R in the same folder as this script, and here I have the files of this folder. Yeah, you can see it's script plot quality. It's here, right there. It is. Yeah. The sample table is also here. There it is. So if we just step through this, I load the data package and then I read this sample table. Let's click it open and have a look. It's only 2 columns, right? The sample ID, which is sort of the prefix of all file names now, and then some additional. Here we could have had many columns, right? In this small example, it's only 2. And then I loop over all the samples, because now there's 1 row for each sample, right? And for each sample, there is now a pair of FASTQ files here in the FASTQ folder. An R1 and R2 file, 2 files for each sample. So let me now, instead of looping over all samples, let me now just set I equals to 1, so it corresponds to the first loop, and then I just run the first line of code and the second one here, because this only creates two text objects, right, containing the names of the files. So we can see that R1 file, this is the name of the R1 file of the first sample, and notice the path. We need to specify that, of course. And here's for the R2 file. So these are just 2 file names now. And then, and this is what this plot quality profile function from dada2 needs. It needs the names of the files that you want to plot the content for. So here I want these 2 files now for the first sample. So if I run this one, it creates a ggplot object. It also has this warning, because obviously this dada2 package hasn't been updated according to the updates of the ggplot, but that we don't care about that. It works. And then we print the plotting object, and here are the results. And let me just zoom it up like this so we get a really big picture. So what do we see here? First of all, we see along the x-axis here the positions of the reads, right? So here is the start of the read, the 5' end of the read, and here is the end of the read, right? The 3'. So we can see that the reads are up to 250 bases long, because this axis goes from 0 up to 250. So that's the first piece of information we get here. Really important one, right? The longest reads are 250. We can also see how many reads there are. 28,331. And the R2 file, of course, always has the same number, right? Because the first read from this one and the first read from this one is a pair. The second from this one, the second from this one is a pair. So these 2 must always have the same number of reads. Then the y-axis here is the quality scores. The Fred quality scores that we call them, or yeah, only quality scores. And if you're uncertain about what a quality score is in a FASTQ file, Google it, and it's not very difficult to understand that. So we see that, and usually we say like 20 is a good, this is sort of rule of thumb. If you have more than a quality score of above 20, it's very good, or good enough at least. Only those below 20 we are a little bit uncertain about. So here we can see the majority of the reads have very high quality, and the plot here now should be interpreted the darker regions, the more reads. So here we have actually all these 28,000 reads displayed, you can say, in one figure, because this is sort of a density. So here we have the vast majority of the reads up here, and the lighter gray, the fewer reads, right? So some few reads are down here with a low quality throughout. This green curve, I don't know if you can see it. It's a little bit thin and difficult to see. The green curve is the mean quality score for all the reads, right? And then you have some median, and you can read in the help file for this function to see what these colors of the curves means. Also, it's possible to display different lengths of the reads here, but in this particular case, all the reads are 250 bases long. All of them. So the maximum is actually the same as the minimum length here. And we can always click that away again. And then, as I said, if you want to understand a little bit more about what you see in this picture, copy the name of the function, question mark, and name of function like this, and you are taken to the help file for it. And here you can see, and the details here, it says a little bit. Yeah, green is the mean, orange is the median, and the dashed orange lines are the 25th and the 75th quantiles. Yeah, 25%, 75% quantiles. So that tells us that between these dashed orange lines, we have half of the reads. So if we go back here, where were they? Yeah, here we have one dashed line and the second one here. So yeah, majority of the reads are in between here, right? And as always, we see that the R2 reads are poorer. R2 reads are always poorer than poorer quality than R1 reads. It drops faster towards the end here. But they are also fairly good a long time. And I mean, if you draw a limit at 20, they are actually quite good. But these are even better, right? And this is always the case for Illumina. Has to do with the order of sequencing. We first sequence the R1, and then the R2, and then the flow cell is a little bit sort of tired when we come to the second round. Okay.